Welcome. Today we're going to talk about supercharging your automated testing. We're going to go through some fundamentals of testing. We're going to describe a kind of playbook of how to add automated testing to your project. And this is going to follow a real-world example of the problems that you hit and then how you choose to bring in tests to solve the problems. And then I'm going to finish with a little case study on what we do in Capital One Wallet. So fundamentals. We're going to talk about why we write tests, the testing pyramid, and different kinds of automated test. So this graph is one of my favorite things. It describes how over time, as your app gets more complicated, you're going to add more and more features. Those features are going to interact with each other. And as you try and test all the different combinations in your app, you basically can't. You find that it takes longer and longer and longer. And if you don't add automated tests, you just grow more and more risk in your app. So aside from that, why do we write automated tests? Once you've added some automated tests, it allows you to speed up your end-to-end release cycle. So certainly the first time you try and do any of this, it's going to take you a lot longer because you probably don't have a clue what you're doing. But once you get over that initial hump, you'll find that your entire project can be released a lot quicker. And if you get it right, then you'll also find that all of this tooling that you've built will allow developers to move a lot quicker because you're writing tests and you can rerun those tests rather than doing manual testing yourself. So you should see a lot of benefits throughout the development cycle. The next thing is once you've got your automated tests running, you're going to connect them up to some kind of continuous integration like Jenkins or something like that. Whenever your code changes, you're going to run the tests and then your product should always be ready to deploy. And certainly your master branch should always compile and your test should pass. So none of the really key stuff in your app should be broken. The other slightly more subtle point is tests are often referred to as the double entry bookkeeping of computer programming. So you're kind of writing what you're trying to do in two different places, and as a result of that, you're going to capture a lot of knowledge about the product in those tests. Another example is as you find production bugs, say, and you fix them, you'll be adding tests even more carefully around the things that got to production, so it helps you to remember these weird edge cases that you had to fix. And then the overall key reason to do this is just that automation improves productivity. So you can think about it like every day as you find yourself having to do a whole bunch of miscellaneous things, you're going to script them, you're going to try and capture them into some kind of regularly scheduled job like a Jenkins job or something. And what you're effectively doing is you're cloning yourself. And the more that you push your work out into automated repeatable units, then you can have bigger and bigger impact. So it's just a really great idea all round. So now we know I've convinced you all, you want to write automated tests. So what kinds of tests can we write? Well, there's a thing called the testing pyramid, which kind of defines different levels of testing. This is the results of a quick Google search for testing pyramid. And you can see there's lots of different varying versions of them. And they have often similar names. I'm just kind of making you aware that you're going to probably hear people use different terminology for different parts of the testing pyramid, but today we're just going to use our definitions. So make sure you're aware if people are talking about kinds of testing, just double check you're talking about the same layer in the pyramid. So here's the pyramid. The tests near the top are, they run slower, they are higher level, so they're typically driving the app through the UI, treating it as a black box. They provide more assurance that the overall app actually works. So it gives you higher confidence your release candidate can be used to go through the main flows. But when one of those higher level tests fails, it can be pretty hard to debug because you're just kind of stuck on a screen. Now, as you move down the pyramid, you're going to get faster tests and they're going to get more specific. And that's good for debugging because, like, say something really low down fails, like the problem is in this unit of code or this component, but it doesn't give you confidence that the whole system works. The other thing to notice here is the shape of the pyramid. you want to make sure that you're pushing tests quite far down. You don't want to have a huge suite of black box tests at the top, because then if you make some minor changes, you have to refactor a vast amount of black box tests. But as a rule, you're trying to keep the tests lower down in bigger numbers and have that kind of shape. So what does it mean for Android? Typically, your unit tests are going to run as like a simple JUnit tests in the JVM, or maybe use something like Roboelectric that does a JVM simulation of the Android framework. And as you go up the pyramid, you're moving into instrumentation tests that require a real Android framework. So they're going to require you to launch an emulator or a device. Let's just explore the different levels in a little bit more detail to help kind of explain them. So let's pretend we have this arbitrary architecture in our app. The internals don't matter too much, but a unit test involves testing a very, very small focused piece of code, usually a class, or even more often a method itself within the class. So unit test is it's everything outside of that code under test is mocked. It's going to test how that piece of code collaborates with its dependencies. It's going to test all these edge cases, and you're probably going to have tests that cover multiple flows of control through a single method. So super, super focused. The next level up we would call component tests, and by that we mean like a collection of units or collection of classes that are a logical component and do a certain thing. So typically that component has like a clear interface, and we're trying to test that whole thing. And I'll talk later about what the difference is between that and unit tests and why it's useful for us. And then integration tests, classically this means checking that two components will talk to each other correctly, and that they actually work with the real examples of those components. So for us, we use these just to check that our APIs work as we expect. And then finally, black box test is testing your entire system. So it's typically a UI test driving your app and using real servers behind it. So that was pretty quick, but now what we're going to do is go through each of those levels in like really careful, specific detail. And I'm going to show you some real world tests that we've written at each of those levels. And the order that I'm going to go through them is going to match the order that you would typically add them to a project by hitting problems as you grow. So the first problem we hit, our development team gets a bit bigger, we get our product in production, and we're having to do a lot of manual QA testing each time we release. This is tedious, it's slow, and unfortunately it's necessary. So that brings us to black box tests. In the simplest possible level, you're automating your QA process. So let's just do an example. It's probably the easiest way. When you launch the Capital One Wallet app, you get a splash screen, get to a login page, you log in, and you get a license agreement. So let's look at what this test is. Just before I explain it, the little pyramid at the bottom right is just reminding us where we are in the testing pyramid, just so that we can kind of know where we are in the bigger picture. So this test is going to do a just basic login. We have a whole suite of test accounts that we use for different scenarios. So in this one, we're just loading our test account for the black box tests. We're going to drive all of our UI tests using these robots. It's just a collection of code that looks for the right buttons and things like that. And the goal of that robot pattern is to make the test super readable. So anyone should be able to read one of these tests and understand what it's doing. You shouldn't have to be a developer to read a black box test. So here we're going to skip the welcome screen. We're going to enter the username and password information, and then press the sign in button, and then check that we saw the terms and conditions and accept it. One additional point is each of these methods, like assert terms and using conditions, or even skip welcome screen, they'll have assertions embedded inside them as well. So we're going to be doing extra checks beyond what you see listed here. So that was great. We just did a black box test. It speeds up our QA testing, makes it faster to release. It convinces us that that flow works through the app. But what's the downside? The downside is if your API or environment is a bit flaky, they're going to fail. Developers typically want to work on a faster build test cycle than this, so they're not going to run these kinds of tests a lot. So we're going to want to do something a bit better for developers. And when one of these black box tests goes wrong, it can be really hard to figure out exactly why it went wrong. So that brings us to our second problem. Developers need tests too. We want to find bugs early in development, and we want to make sure our tests are super fast so that developers can run them, and we don't want it to slow them down. We want to catch a lot of the common bugs early. So what do? Unit tests. We've already talked about what they are, but these are tests that you're going to write as you're going through the code, and they're going to check that the very low-level things you're writing work. So which unit test should I add first? Like, it can be kind of intimidating, right? Like, it's a lot of different kinds of tests you could write. I would recommend doing them in like the simplest order first. So let's take one that's really easy, static utilities. So we've got our list of transactions here, and you can see we have like dollar amounts for them, and obviously something's being done to sort the transactions. So the first time you write that code, you probably don't add any utilities, but then you release to production and you realize you forgot to check for null in one of the fields. So then you end up creating a safe compare method, and that copes with null. And so since this was a crash, you write your nice little static utility tests, and we check, oh look, when the right hand argument is null, I get back -1, which is just how it's supposed to work. And then another example, let's say we are displaying those dollar amounts on the transactions page. Well, the first bug we find is we get into QA and a product owner spots that you forgot the trailing 0. So now we want to make sure we add that case into our test so that we never forget to add the trailing 0 again. And oh look, you give them the new build, and now you get to $1,000 and realize you should have had a comma sign after the first character. So something as simple as this, like, how is this number formatter work? How does it work? The test can give you loads of great examples showing you exactly how it should look. And this sort of thing's great when you have code that's like a regular expression or a formatter or something that might be quite hard to get your head around, but the test just shows you this is exactly how it should work. And we'll actually paste these tests and show them to product owners to be like, here you go, these are the way it's going to display. And that makes it really simple. So we've done some static cases. What about edge cases, crashes? So let's do the example again with some transactions. We're in production, and then one of our APIs suddenly returns like a null reference ID in one of the fields. So here's a test that captures that scenario. Let's break it down step by step. So in this case, we're going to simulate that our API calling layer has returned like an error to us instead of returning a list of transactions. So we push that into the fragment. We check that we still have this loading message and that it shows the error message it's supposed to show. In the original code, when it crashed, this is where it would crash. This test would have already failed by here. And then now we're going to check, oh look, not just that it shows the right thing, but did we get the analytics we wanted to come back, going to our analytics server? And then we also decide, oh, we want to send this to Fabric to see a handled exception. So we're going to check that that gets called. We're going to pass in an argument captor, which is basically something that allows us to check what got sent. So here we've mocked the logging util and we're feeding in our own captor, and then we can say check that we got called and this text was in the thing that you were trying to send. So we've not only got a test that now covers our exception handling to make sure our code doesn't crash, we've also got the right kind of analytics and logging being triggered. So what about other kinds of things that will help convince you to write test? So one example is something that's just really important, like you're writing code for it and you think, oh man, I really don't want to forget about this. This would be a really big deal if I missed it. So one example would be, say, like setting the window to be secure, because you want to make sure it's hard to screenshot and it be, let's see, what else do? Oh, you stop it appearing in the task manager preview as you're switching apps. So pretty simple little test, but something that you probably want to make sure you have so that you can be sure you never accidentally drop this. And then the final one in the list is, this is typically where people start when they're explaining unit tests, but it requires you to think a little bit more carefully. So I've actually left it for last. With the unit test, we want to check how your code plays with other components. So let's dig into an example of that. Let's talk about card lock. In the wallet app, you can come in, you can press the card is on button, and it gives you a pop-up, and you can lock the card, and now you can't use the card. So it's good if you've accidentally misplaced your card for a while. So what does a test look like for that? This unit test is testing the, I can't remember if this is an activity or a fragment, but the activity has a card controls feature, and this is a component which tells it the feature flag configuration for the app. And so inside our first test, we're saying when this mocked feature is called, I want to return true to pretend that it's enabled. And then in that case, we want to make sure the card lock controls are visible and that the text, this card is locked, appears. And then we don't want to be able to use the rewards in that screen, so it needs to be gone. And then we have the reverse test. When you're calling the feature flag component, we want to return false and check that the card lock controls are gone and that you can now see the rewards again. So here we go. Let's recap what was good and bad. So unit tests are fast, they're great for small components, and it forces you to write clean testable code. What's the downside? Well, the downside is that the unit tests are usually tied very, very tightly to the code that you've written. So if you want to refactor something, you usually have to rewrite a lot of unit tests. The other thing that I've found is with unit tests, I think that it can be too easy to miss the gap. So you could have a lot of unit tests, but often it doesn't convince me that the overall component works correctly. Like the collaboration between them might also not work correctly. So I find like the whole doesn't equal the sum of the parts for unit tests. So that brings us to our problem number 3. Our unit tests, don't guarantee everything works correctly, and they often need to be refactored a lot. So I'm going to go through show you some code now. This real code we had in the product, and found it difficult to work with for unit tests. So this one is a situation where we have kind of a component that makes multiple API calls. It makes these one API call, gets a response, does some crunching, and sends a second API call. And so we had these. This was when we were using retrofit 1. It had some callbacks, some events being sent to the bus, listening to the bus, and then second API call, and then another callback again. So when you write the unit tests, each of these blocks of code ends up with a bunch of unit tests, and you get to the end and you want to refactor it and you have to rewrite them all, and it didn't really prove the whole thing even worked. So that brings us to component tests. Let's take a real world example again. So we've got one of these API components, and we find that we have a crash when the server returns something unexpected, like say it sends back HTML instead of JSON. So we want to test this edge case. Let's do a quick recap of what this component looks like, just so you can understand it more easily. We're trying to test this highlighted API component. So what happens is the UI sends a request to the bus, who passes it on to the API component, who makes an HTTP request, gets back the response, and then sends it to the bus, which passes it back to the UI. So that's what the code is normally doing. So for us to test this, we can just throw in our component test to drive the test with a bus, and then the server at the bottom, we can now switch that out for a mocked server. And now we've got our API component under test. Disclaimer, the astute amongst you would have thought, well, why are you testing via the bus? Why don't you test the API component directly? And that's totally fair. We probably should have cleaned up that interface to the API component and driven it directly instead of using the bus. I accept that, but that's not what we did, so we'll stick with our example for now. So we're trying to write this edge case where the server returns HTML instead of JSON. So here's an example test for that. again, little pyramid at the bottom right, we're now up at the component test level, so we're above a unit test. So the first thing we do is we're going to stub our API response to return HTML, and then we're going to have our test post a new request. We're going to then check that we got an event back from the bus and that it was an error. And so what typically would happen when we had the crash was our API component just hit an exception, never sent a bus response, and the user could be sat there forever with a spinner. And so this test is capturing that and making sure that the component as a whole always returns a bus event even when something bad happened. So now let's do something really similar, like an edge case that's also hard to do manual testing for. So it's basically the same thing, but the correct 503 response. So we have a scenario where if our system is down for maintenance, the server could return a 503 with a message in that says it's doing system maintenance. So you can imagine how hard that is to test, right? You have a QA environment with lots and lots of customers on it, and so we have to bring that down temporarily while we test. So this component test is capturing that and checking that we got the error message we expect back from the component. So we just talked about some edge cases. We could also, as you'd expect, we can use them for some happy path cases too. So we can do some success tests and just validate that the contract works as it should. So I'm using a different API component here, the one that returns transactions to us. So we're just going to stub it to receive some transactions instead, send it a bus event to tell it to go do its business, and then basically check that we got passed back a list of transactions in the response. Now, if we wanted, like maybe this component also has other responsibilities, like maybe it's supposed to save to the data layer or trigger some other notifications or whatever it is, you can add those in here too, and that would be validating that the whole component is behaving as it should. So this brings us on to component UI tests. These are just a special case of a component test. In this case, the component under test is a piece of UI. Let's talk about the easiest reason you would force yourself to write them. So for us, there was a kind of a really convincing situation. We support third-party payment, so you could have Android Pay or Samsung Pay, and you can add your Capital One card to them. And what we do is they will redirect you into Capital One Wallet to confirm the activation and set everything up securely. So we have these situations where we have a third-party app that is calling into Wallet. So we want to write tests for those because it's really hard to get all of these third-party apps in the right state that work in your test environment. We have to get the card in a special state for us to be able to activate it. So here's an example of one of these tests. So this UI test is basically setting the stubs up and then doing a login, and then we're using our robot to come in and check that we got to the activate screen. I've got examples here from both Android Pay and Samsung Pay, and then we're checking that when we press activate, we can get to the completion screen and we get the message we're expecting at the end. So this whole sort of sequence of screens is driven from an intent that has a specific contract to launch them, and that's how the tests end. So these kinds of things, hard to test, really good example where we wanted to get them automated. So just as an example, that was a really simple one, but we have more complex one. You could be activating like multiple cards in Samsung Pay, or you could be doing like an Android Pay test as well. So slightly different flavors of the same thing. So that was cool. That was useful. We had our difficult to test flows. Now that we like them and we're really happy with writing these UI tests, we can kind of scale that up and use the mock out all the responses and use them in lots of other places too. As developers, we just want to know that whether we broke something or not. So we want our test to generally insulate us from environment issues. So let's go back and look at the login test from the black box test. So this is the code I showed you earlier for a black box test that has real API calls. So you can see we're at the top of the pyramid, and there's nothing mocked in here. This is all real users and real UI. So to convert this into a component UI test, all we do is we basically come in and we stub the API responses, and then we launch it in a special way to make sure the mocks will get picked up. That's the only difference. Everything else here is the same. You still come in and you drive the UI. So in this happy path example, we've asserted we can see the terms and conditions screen. How would we turn this into an error case test? So well, let's work through what changes we'd have to make to also cover the error path. So let's rename the method, or copy paste and change the name. So now we have an incorrect username or password test. We need to make sure our mocked response is now the correct API response. So here we're going to override the mocks and return a 401 with a certain error text in. And then all we need to do is change the assertion we make in the login robot. So we're just checking that we got the username or password error. So you can see it's pretty easy to just tweak existing tests you have and cover lots of screens. So another cool thing about these is you can trigger screenshots at each point in the process, and we run jobs like this once a day that just create a map of all the screens in the app. So this is an example of the full login flow and first time user experience. And then here's a bigger example, like a whole set of flows throughout our new discounts feature. So this is, again, just super cool. You can see this. It shows your product team what's happening, why the tests are useful. And if you suddenly need to check, like, oh, what does the screen look like on this size machine or whatever, you can run these tests and go look at it. So to recap, component tests, you're validating the component is correct at its interfaces. They're more resistant to internal refactoring. They're not flaky, and you get free documentation from the screenshots. And then the only downside really is that they're slower than unit tests. So that was all good. Brings us to another problem that we have. We've been developing a long time, and we were asked to integrate with these different APIs. And in a typical flow, what you do is you're building all of the client code, including all the screens and stuff like that, and then you start trying to test it near the end. Like, does this actually work? And in the old days, as developers, we would be doing manual testing on the device, and then something would go wrong, and we'd have to look at the API responses. And so you would find integration bugs quite late in the development process, and that's a really bad idea. That brings us to a thing which I like to call risk-driven development. What we want to do is we want to test these APIs as early as possible, and that makes us sure if they work properly, or maybe we've just completely misunderstood them. So let's talk about integration tests. So for us, we're basically driving the API and checking it works. So let's talk about how the integration tests relate to component tests, because they seem quite similar, right? So this was what we did for a component test. To convert this into an integration test, all we actually need to do is take the mock server at the bottom and just use the normal server. So it's actually easier to write an integration test than a component test, because you don't have to deal with any mocking, which can be hard the first time you do it. So let's go back to the card lock example we did earlier and just look at what one of those integration tests might look like. So we have test card lock status update success. So we're going to log in, doing real API calls to log in with this user. Going to check if the card is locked. Then we're going to change its status. So let's say it's unlocked. We're now going to lock it. And then let's unlock it again. So we're basically checking we can go forward and back through the states. This seems kind of trivial, but it's actually really useful, because the first time new APIs come out, people are changing their contracts, or they're going down a bit too frequently, and it makes it really easy for you to just run a quick test and know exactly why something failed. So now that we've been adding these tests, we can see whether the APIs are working. The next thing that happens is, every now and then something weird happens, right? And it takes you a few hours to dig in, like, why is the client behaving this way? And then it turns out you debug it and some ID is missing. So let's take an example here. Like, we're pretending it's not pretending, sorry. This is logging in and getting the cards that a user has. So, maybe we originally had an assertion that was just like, check there are cards, and if not, it would fail. And when that happened, you'd have to dig into all the logs to figure out why. But when we hit a problem that we've had to debug and it wastes a bunch of time, we really need to go back and fill in the assertion. And here we've added the first argument to the assert false with a nice helpful error message. No cards were returned for this test account. And that means when someone sees one of these errors, they know exactly why it failed. And then the second example here is this reference ID when it was missing. Now that it's happened, we put in something that says the reference ID is missing. So bang, like they know the cause straight away. And then because we're good developers, we also put in the impact so that anyone looking at this can understand. So the impact here was transactions and receipt images might not be available, or whatever it is. So the good thing about these assertion messages is when you're running your tests, say you're viewing the results in Spoon or in JUnit test reports in Jenkins, whatever it is, those error messages just jump out at the very top. So here, anyone looking at this can tell straight away, oh, there were no payment cards returned by the API. This is an older version. It should also have the test account name in there. So just making it really easy to understand errors. And then the next thing we can do is not only do we have these tests, we can pre-compile the test APKs, do it one time, and then we can push those artifacts into a Jenkins job somewhere that just runs every hour. And what it's doing is it's got a nice stable version of those tests. It's running every single hour, and it's sending the output to HipChat or Slack or wherever. And this is really useful because as soon as you see some kind of problem, you can jump in that room and see, oh, something's down right now. Or you can use it to check the downtime for the last 2 weeks or whatever. So integration tests, trivial to write. They automatically diagnose API issues. And if you improve your assertions, make that even easier. You can turn them into API monitoring tools. And another really subtle benefit is you can take an older branch or tagged version of your app and run those once a week or once a day. And so maybe you have a version of your app that's been in production for 6 months that everyone's forgotten about. You can keep running those tests once a week. And then if the server team accidentally retire some old API without telling you, you're going to notice that. And then the downside of integration tests, of course, if your environment's flaky, then your tests are going to fail. I would argue that's okay though. It's a con, but it's also why you can run the tests. Like it can help you figure it out. So let's just step back from that for a second and just talk about the development process that we use in Wallet and how many of the things that I've described, how they play into it. So this is our flowchart. Someone creates a pull request, then the pull request builder, before you merge, is going to run the unit test, the component test, component UI tests. And when those all pass, you're going to merge the branch, and then at that point, you run them all again in master, plus the ones that are less stable. So, your integration tests and your black box tests, they might be a little flaky. So you only really want to run those after the build, after the merge. And here's an example of where Sam Edwards on our team, he merged something to master, and you can see, the hooks coming into HipChat saying everything passed except the integration tests. And that's okay, because we can click in there and see, oh, this was like a known issue at this time. So what does our testing pyramid look like? These are real numbers and times from our team. So our team size was probably about 5 or 6 by the time I took this snapshot. And you can see that we had over 300 black box UI tests, over 100 integration tests, over 140 component UI tests, more than 150 component tests, and over 2,000 unit tests. And you can see the times for each of these. So you can see the UI tests are taking longer, and we're actually going to start sharding those tests across multiple Jenkins slaves soon, because we want to make sure really all of those tests are running ideally in like under 10 minutes. If we could, 5 would be awesome, but 10 minutes isn't too bad. And another point here is to say that at the moment the QA team own the black box tests at the top, And as a dev team, we own all the ones underneath. So we've been going through this. We've talked in a lot of detail. What are there any principles? Like as a team, it can be hard to remember all that stuff. So we need guiding principles to help us like anchor ourselves and like what are our development rules. So I would say that all code needs automated tests. So generally speaking, anytime you're doing a pull request, if you haven't added automated tests, you should say why. But because I'm a nice guy, I'm going to take a more reasonable and easier to sell position here. So if you want something easier to meet, let's just say that every bug needs an automated test. So if something got into production, or it was found by your QA team, or even if it went into master and the developer found it after the code was already merged to master, all those cases are like 100% clear cut. Like you need an automated test. If you impacted someone, you probably wasted a lot of their time, and so you need to make sure you don't make that mistake again. One other disclaimer here. Let's say you're building a throwaway prototype. I'm not going to be as fussy then, but when you've got a real production app, I'd say the rules are a lot stricter, and you need to make sure you're covering any bug with an automated test. Next one is, this is quite subtle. You need to write your tests at the same time as writing the code. And I see a lot of teams don't do this, and it's a really, really dangerous thing to do, because what you're doing if you write your test later is you're losing a lot of the benefits that automated tests actually give you. So the first benefit that automated tests give you when you write them is they force you to create testable APIs. So let's look at an example. Let's say in our app you can click a button to buy something, and first time around you write the code like this. So within your method you're saying new production credit card processor, make payment, blah blah blah. Now you try and write a test for this, you realize, oh damn, like every time I try and test this, I'm actually creating a production credit card processor, which might start firing analytics to my production system, or all kinds of scary stuff like that. So what you actually need to do is called dependency injection. You take your dependencies, which in this case is the credit card processor, and you move that into a parameter that goes into the method or the constructor. So by doing this, the production code can put the production credit card processor in, but when it's under test, you can feed in a different one, and that will allow you to test all your different error cases. So by doing that, we are forced to consume our own APIs, and you write your code as if it's an API. So it's making you write it testable from the beginning. If you write the test later, you're going to find, oh my god, it's really hard to write all these tests because I didn't design it properly. So now I have to refactor everything, and I'm probably going to introduce bugs as I go. So this is a really killer reason why you write the tests as you go. The second reason why you want to write the tests as you go is because by having those tests, you can run them as you code, and it's going to speed up your build test cycle. So you're writing these tests and you're refactoring things. In test-driven development, it's like red, green, refactor. So as you're going, you're writing your test, it fails, you fix it, and then you can refactor the code and check the test still passes. So there's two things in this. One is the designing it right, and one is speeding up your development cycle. So write the tests early. Don't write all your code and then write the tests at the end. And then I just mentioned it, but I want to really re-emphasize it here. You should write a failing test before making it pass. And we've still seen situations where we've been sloppy and we've written the test, and it passes and we move on. And then we actually introduce a bug that should have been caught by the test, but because we never made the test fail, we didn't realize that the test wasn't quite covering the thing we wanted it to cover. So you always want to write a failing test first, because otherwise you're going to think you have good coverage, but your test might not actually catch any bugs. So definitely do that. It's a really easy mistake to make. The next thing you want to figure out is how do I choose where to put my test? And the key is you want to push the test as low down the pyramid as possible. So you don't want to have black box tests for everything. Let's imagine that I want to test a login page error, and there's 20 different scenarios that can cause login errors. I don't want a black box test for all of those. What we would do is, if those scenarios result in maybe interesting HTTP responses, you would probably capture those as integration tests, so that you want to be sure your contract hasn't changed, and you want to be sure you understand which HTTP responses and bodies you get for these different scenarios. So you're probably going to want integration tests for those. And then once you've got those, you can probably make do with a component UI test that checks that your screens show the right thing when they get one of these errors back from the like your API component. So you basically have the integration test that manage the contract with a server, the component UI test that checks the UI does what it should when it receives certain events, and you have a component test that checks that that API component returns the right events given certain mocked responses. So in that case, you've broken it into smaller tests and pushed them down the pyramid. And then the final part, which is sounds kind of obvious, but make sure you run your test before merging pull requests. Anytime that your tests start to go red, it's very easy to accidentally add more problems, because as soon as they're red for a while, people assume they're not going to pass, and they start accidentally breaking things on top, and it gets harder and harder to clean up. So keep your tests green, and the easiest way to do that is to force people to see the results of them before you merge your code. And so to wrap up, here's the mandatory recruiting slide. We're looking for another team lead, so hopefully stuff in this talk interested you. Our team's really passionate about automated testing and continuous integration. We like to learn and share, and we've also done some cool things in the app. We were launch partner for the Foursquare's new Pilgrim SDK. We were the top-rated finance app by US Bank, and we were also the first US bank to ship native Android contactless payments. So I hope you enjoyed the talk. I'll break now for questions, and otherwise, thank you very much for coming.